Example 2 introduces another big type of question that we're going to look at. And when certain big types of questions throughout the year, I give them special names. So these ones, I'm going to call them multi-revolution questions. And by giving them special names, I find that that helps you connect to your thinking of saying, oh yeah, we solve it this way. So if you can recognize something and give it a name, usually that helps you solve it. And the names that I give it are usually connected to how we solve it. So multi-revolution questions, this is the name that I've given to this, and we're going to see why we call it this. So in this multi-revolution question, it says, solve sine 3x equals 0 between 0 and 2 pi. So we've solved sine equations before. We've solved between 0 and 2 pi before. What's different in this question? It's 3x instead of just x. Now you might be tempted to divide both sides by 3, but you can't do that because that 3x is inside your function. So you can't just divide both sides by 3. And so what do we do with this question? Well, a couple of things. First of all, if it was just sine of theta, if this was a theta in here, we'd have no problem. We'd say, when is our y-coordinate equal to 0? What values? If it was just a theta, you would say theta equals 0, where else? Pi and 2 pi. Okay? This is what you would say between 0 and 2 pi. This is what you would say if it says theta. But we don't have theta here. What's underneath this theta? It's a 3x. So instead of writing theta here, I'm going to write 3x. And that's not too crazy different than what we've done before, but sometimes it feels weird when there's two things there instead of just theta. Okay? Now, because it's a 3x, this also has an effect on our domain. For example, if I got you to pick a number between 1 and 10, okay, and then I got you to multiply that number by 3, everybody's numbers would be between what and what? If I got you to first pick between 1 and 10, and then you multiplied it by 3, what are our numbers between now? 3 and 30, right? Because you've multiplied by 3. So in this question, if we look at the original domain, 0 less than x less than 2 pi, if we multiplied everything by 3, because now we have a 3x, well, 3x would be between 0, right? Because 0 times 3 is still 0, and 6 pi. Does that make sense? If 1x is between 0 and 2 pi, then 3x's would be between 0 and 6 pi. In the same way that if you picked a number between 1 and 10, and then multiplied it by 3, then your numbers are between 3 and 30. And this is why we call it a multi-revolution question. Because 1x is one time around the circle. If 1x is one time around the circle, then 3x's is 3 times around the circle. And so it goes around the circle more than once, hence the name multi-revolution question. So when we solved 3x, 0 pi, and 2 pi, we solved that only once around the circle. What about the second time around the circle? What else do I have to add to this? Right? We have 0, we have pi, we have 2 pi. What's this one going to be? 3 pi. And then 4 pi. That's twice around the circle. We need to go a third time around. What's this one going to be? 5 pi. And finally, ending here, 6 pi. Now, the textbook does this sometimes. Notice our domain here. Okay? Notice there's an equal sign with the 0. There's not an equal sign with the 2 pi. And so when I multiplied everything by 3, it's 0 less than or equal to 3x less than 6 pi. So even though I solved it 3 full times around, I now have to go and either put an x through this one or erase it, because that one's not going to be included, because 6 pi wasn't included in our domain. So now we've gone 3 times around for 3x, and we've got 5 answers. But in a question like this, which says solve, what do you think they want us to solve for? X. We haven't done that yet. We've solved for 3x. If you had 3x equals 10, how would you solve for x? You divide both sides by 3. So we're going to do the same thing here. To solve for x, we have to take all of the possible answers and divide them by 3. Now, of course, 0 divided by 3 is still 0. Pi divided by 3, 2 pi divided by 3, 3 pi divided by 3, and of course you could simplify that to just pi if you'd like. 4 pi divided by 3 and 5 pi divided by 3. And look at our final answers for x. Are they between 0 and 2 pi? Because that was our goal, right? X, our domain for x should be between 0 and 2 pi. In order to do that, we needed to temporarily look at 3x between 0 and 6 pi, so that when we did the horizontal compression, all of our answers ended up being between 0 and 2 pi.
So 3x in sign is just doing, is compressing the period by
The 3x in that sign is a compression, right? It's a compression of our period by 3. So graphically, I don't know if this helps you visualize what happens, but if I normally think about my sine curve of 2 pi, and my sine curve goes up to 1 and down to -1, divide this into 4 equal sections, and it starts in the middle going up, middle, then max, then middle, then min, then middle. This is my normal sine curve. And in 3 full revolutions, I'd also hit 4 pi all the way to 6 pi. Divide that into 4 sections, divide this into 4 sections. Middle to max to middle to min to middle to max to middle to min to middle. This whole graph with, so this green graph here, this is y equals sine x. This whole graph now gets compressed, here's 2 pi, to a period of 2 pi over 3. And now we have a full period right in there. So we go middle to max to middle to min to middle to max to middle to min to middle to max to middle to min. Perfect. So what we did in our question algebraically, so this is sine 3x. What we did algebraically is we initially just said, I'm going to ignore this 3x and think of it just as sine theta. And there's my normal sine graph, just solving normally for 3x. But I'm going to have to solve 3x's between 0 and 6 pi. And I found 0, pi, 2 pi, 3 pi, 4 pi, 5 pi, and 6 pi, but I took that one out because it wasn't in the domain. I then said that was easy to find those answers between 0 and 6 pi. And now if I take each of those answers and divide it by 3 or multiply by a third, which is the compression, then I'm going to find all of those answers. And of course, the 2 pi 1 wasn't included, just like the 6 pi 1 wasn't included. And so we call this a multi-revolution question because it's easiest if you first say solve for the inside, which is 3x, but 3x's are between 0 and 6 pi, 3 times around, rather than between 0 and 2 pi. And we got these solutions. Now in part B it says state the general solution to this problem. So we just solved it here between 0 and 2 pi. How do we write the general solution? Well, if we go back to the steps that we originally wrote for the general solution, right? The general solution says solve like normal. Well, our new normal for multi-revolution questions is kind of complicated, but we solved it between 0 and 2 pi. Now all we would need to do is add 2k pi to each of those answers. So it's going to be a long answer. So for part B, I'm going to just take a picture of our, we already figured out we already have solved between 0 and 2 pi in part A. So in part B, when we go to write all of our solutions, we can go x equals, and here's our new format, this big squiggly bracket here. We can write each of these answers, pi over 3, 2 pi over 3, 3 pi over 3, which is just pi, 4 pi over 3, and 5 pi over 3. And add 2k pi to each one. And there's the general solution for this one. There is a more elegant way to write the general solution for multi-revolution ones, but for right now, we'll just do it this way because it follows our steps nicely from before. So our steps for the general solution, solve between 0 and 2 pi. And once you've solved between 0 and 2 pi, then add 2k pi to each of your solutions and you have your general solution. No problem. So question number 10 for practice on these ones.